Hi, this is the first video for Chapter 14 for Exponentials and Logs for Year 1. So in this video I'm going to show you and talk about what something that's an exponential is and what their graphs look like. So an exponential is basically something that's got a variable that's an index. Exponential just comes from the word exponent, which is just another word for indices or powers. So if we have a with a little x, the x is the index or the power or the exponent, and the a is called the base. This is going to be a number, not necessarily a whole number, but it's going to be a number. So the x is the variable, that's the thing that changes. So when we are looking at graphs in the form y equals a to the power x, the y coordinate is whatever the base is to the power of whatever the index is. And they have very distinct shapes, which you need to try and remember what they look like in general so that you can sketch them. So let's just have a little look at them. So let's think about y equals 2 to the power x. So if we had to plot that graph, we would choose some values of x. So let's start with x is 0. 2 to the power 0 is 1. So when x is 0, y is going to be 1. When x is 1, 2 to the power 1 is 2. When x is 2, 2 squared is going to be 4. When x is 3, 2 cubed is going to be 8, and so on. So you can see as x gets bigger and bigger and bigger, more and more positive, y is increasing at a faster and faster rate. In fact, it's growing exponentially. So that's where we get the term exponential growth from. What happens when x is negative? Well, when x is minus 1, 2 to the minus 1, if you think of your index laws, is 1 over 2 to the positive 1. So when x is minus 1, y is going to be a half. When x is minus 2, 2 to the minus 2 is the same as 1 over 2 to the positive 2, which is a quarter. So when x is minus 2, we're going to have a quarter. When x is minus 3, we're going to have an eighth. When x is minus 4, a 16th, a 32th, a 64th, and so on. So it's getting, as x gets more and more and more negative, y gets smaller and smaller and smaller and smaller. It won't, however, become 0. So this is on a graph. If something is converging, then we end up with what we call an asymptote, which you'll have seen before when you've drawn reciprocal graphs and trig graphs. So we have an asymptote. And the asymptote in this case is the x-axis, so that's got equation y equals 0. So that's what y equals 2 to the x looks like. Now if we look at y equals 3 to the x, well again, 3 to the power 0, when x is 0, y is going to be 1. So this also goes through 1. When x is 1, y is 3. When x is 2, y is 9. When x is 3, y is 27. So we're going to get the similar sort of thing, apart from it's going to grow or get steeper and steeper at a faster rate. When x is negative 1, that'll be a third. When x is negative 2, that'll be a ninth. Then it'll be a 27th, then an 81th, and so on. So it's going to also converge, but it's going to converge faster. So this will also have an asymptote at y equals 0. Y equals 5 to the x. Well, that's going to be, go through 1 here, 5 to the 0 is 1, and then it's going to be at the 0.15, the 0.225, the 0.3, 125, and so on. So this is going to grow very, very, very sharply and converge quicker. Okay, now you can see from a sketch point of view, they look pretty much the same, and they will do. So all you need to remember really is the general shape, where the asymptote is, and where it crosses the y-axis. Really, other than that, you can't really tell much difference between them. Now you would think that y equals a half x, because this is smaller, that it would look the same but not grow as quickly. Well, actually, it's slightly different. 1/2, or 1/2 to the power 1, is 2 to the minus 1. So instead of y equals a half x, we can write it as y equals 2 to the minus 1x. And then we can use our index laws to times them two together. So that's y equals 2 to the minus x. Now this, because there is a minus that's gone into the function, we think of this as a graph transformation, this is a reflection in the y-axis. So this is of the form f of minus x. It's inside the brackets, it's affecting the x coordinates, so that is a reflection in the y-axis. So we are going to reflect y equals 2 to the x in the y-axis. And that's just going to look like that. So it's going to come down, difficult to do with a little pen. That's going to be 1 there. And then we've still got this horizontal asymptote that is unaffected by that reflection. Okay, now you really need to remember that y equals 2 to the x looks like that, and y equals 2 to the minus x looks like that. Okay, so those should be the ones that you memorize. Okay, right, now what we need to be able to do is apply our rules for graph transformations we learnt a while ago, and apply them to these exponential graphs. Okay, so y equals minus 2 to the power x plus 3, that's what we want to sketch. So if we think of our baseline graph, f of x is 2 to the x, we know what that looks like. And then think about what has happened to this to get this. Well, we've got minus f of x plus 3. So we've got two transformations. First of all, we've got this minus. That will happen first because we're using BIDMAS. Multiplication happens before addition. So the first thing is going to be a reflection. But because it's on the outside of the function notation, it's affecting the y coordinates. So that's going to be in the x-axis. The second thing that will happen is that we've got this plus 3, also outside the function notation. So again, this is affecting the y coordinates. This is a translation. So if it's affecting the y coordinates, it's going to be a vertical translation. In this case, it's going to move up by 3. Now, if you need to, do a series of little mini ones, just to give you an idea before you commit. So 2 to the x looks like that, going through 1. Minus 2 to the x will look like that, going through minus 1. And the asymptote is still going to be the x-axis. So when you move that up by 3, the whole thing is going to move up by 3. Now, top tip, if you're drawing any graphs or sketching any graphs with asymptotes, place the asymptote first. If this is y equals 0, if that moves up by 3, then it's going to be at y equals 3. We can work out where it crosses the y-axis either by considering this. So if this moves up by 3, it's going to go to 2. Alternatively, if you say x equals 0, minus 2 to the 0, or 2 to the 0 is 1, so minus 1 plus 3 is going to be 2. I've just realised I put 0 there rather than 3. So it's going to go through 2. So then we draw it in. So it's upside down. It's converging to y equals 3. And it's going to look like that. Okay. Let's have a look at another one. So remember, this is the same as 2 to the minus x. So if we say f of x is 2 to the minus x this time, because we know what this looks like. So this is just f of x minus 2, which is a translation. And again, it's vertical because it's outside of that function notation, so it's got to go down by 2. So we know it's going this way. We know that it's going to go down by 2. So instead of converging to the x-axis, it's going to converge to minus 2. And then we can work out where it's going to cross the y-axis. If x equals 0, 2 to the 0 is 1, minus 1 is negative 1. So it's going to come down through minus 1 on the y-axis, and then it's going to converge to y equals minus 2. Okay, this one, if we think of f of x being 2 to the x, well, the x has been replaced by an x plus 3, so this is in the form f of x plus 3. X plus 3 has gone into the function. So this is a translation minus 3, 0. It's going to move left. Now, if you think that 2 to the x looks like that, if you move it left, it's not really going to look much different. That horizontal asymptote is unaffected. Okay, the only thing that's going to happen if I move that left is that it's going to cross the y-axis at a different place. That's all. So if I say x equals 0, that's going to be 2 to the power 3, which is 8. So that's going to go through 8 there, and then look like that. Okay, and it's just going to converge a bit later on, that's all. Now we can consider this in a slightly different way, using laws of indices. If we use this rule, which you're used to using, if we say that y equals 2 to the x times 2 to the 3, then we could also, that's 8. So we could consider this as a multiplier. So this is now of the form 8 f of x. And if you think about this now, if the normal graph goes through 1, and this is stretching it in the y direction 8 times, the asymptote is going to be unaffected as it is there. The y coordinate will be 8 times bigger as it is there. So you can consider it in 2 different ways. The result is the same. Now what I would like you to do is have a go at those ones there. Pause the video